this example, we're going to explore some of the ideas that you have read about or that we have discussed in class. So begin by supposing that the length of a rectangle is 1 foot longer than it is wide. Let's find a function that expresses the area of the rectangle in terms of its width. Okay, well, maybe it will help to first of all draw a diagram. Here we have a rectangle, and this rectangle has a width and it has a length. Just a quick note, I hope that you understand that width and length are both different words to describe more or less the same thing. You see, one person's width is another person's length. If the person drew the diagram this way, then we would have the width and the length. So in reality, when you're drawing these diagrams, you can't go wrong as long as you choose one side to be a width and one side to be a length. Here is the diagram that I'm working with. I have a width and I have a length. Of course, the area must be the length times the width. And in many ways, this is the relationship between area, length, and width. We are not quite there though, because the goal of this problem is to find what would be the area in terms of the width only. Right now we have two different variables that the area is depending upon. We need to write this as the area depending upon width only. So we need to look for some condition. Is there a condition in this problem that would let us relate the width to the length? Yes, there is. That is to be found right here. It says that the length of the rectangle is 1 foot longer than it is wide. That is just another way of saying that the length is equal to the width plus 1. Good. So whatever you solve for goes away, and in this case we just solve for the length, which means that the length can go away. Over here we now have that the area is equal to, instead of this L, we can use what the L is equal to. So it's the area is equal to the width plus 1 times the width. If we simplify this a little bit by distributing, we get the width is W squared plus W. Now we do have A in terms of W, so we really have a function. In fact, we may write this as the area as a function of W is equal to the width squared plus the width. Could we go a little further? We definitely have answered this question. Suppose it goes just a little further. Suppose it tells us that the width is changing as a function of time. Maybe the width as a function of time is t squared plus 1. Do you understand what that's describing? It means that when the t is 0, then the width would be, well, that would be W of 0 equals 0 squared plus 1, which is 1. So when the time is 0, the width is 1. Maybe we ought to give some units. Let's have t in seconds. That will allow us to describe what's happening a little more clearly. So when at t equals 0 seconds, the width is 1 foot. When t equals 1 second, that's W of 1, which is 1 squared plus 1, which is 1 plus 1, we get 2. So when t equals 1 second, the width is 2 feet. I'll do one more. When t equals 2 seconds, we're evaluating W at 2. That gives us 2 squared plus 1, which is 4 plus 1. So when t equals 2 seconds, the width is 5 feet. And so on. Alright, so This is describing how the width is changing as a function of time. The reason for this extra detail is so that we can think about the meaning of the following. Let's find the area, this area function right here, composed with this width function right here. And we'll think about its meaning. So let's figure out what is the area composed with the width as a function of time. This means A of W of t. A of W of t is equal to, well, it's equal to, we'd have to take our rule for W of t and put it into our rule for A, wherever we see W. So that's going to be this. So see, the first thing when we put a W into our function for A, we get W squared. So we have to take our rule for W, which is t squared plus 1, and then square it. In fact, I'm going to write the rule for A. I'm going to put it right here. So this W squared is why we have the quantity t squared plus 1 squared. The reason for the t squared plus 1 is because that is our rule for W. There's also this plus, right here we have our plus this W. Well, what is our rule for W? Our rule for W is right here. It's t squared plus 1, so this is t squared plus 1. We have A of W of t. On the right-hand side of this function, we see an expression only in terms of t, so this is really A of t. So A of t is equal to the quantity t squared plus 1 squared plus t squared plus 1. What kind of questions can be answered with this function? Well, here is the type of question that can be answered with this function. Suppose t is equal to 0 seconds. At 0 seconds, what is the area of the rectangle? Let's put that question right here. At t equals 0 seconds, what is the area of the rectangle? We can use this function to answer such questions. Let's find what is A of 0. A of 0 will be the quantity 0 squared plus 1 squared plus 0 squared plus 1, which becomes 0 plus 1 squared plus 0 squared plus 1. Simplifying this, we get 1 squared plus 0 squared plus 1. 1 squared is 1 plus 0 plus 1, which is 2. So when t equals 0, the area is 2. The units here would be square feet. The units for t are in seconds. Let's do another one. How about, what is the area of the rectangle when t equals 2 seconds? To answer that question, we evaluate the function that we've created at t equals 2. So A of 2 is equal to the quantity 2 squared plus 1 squared plus 2 squared plus 1. Simplifying this, we'll get the quantity 4 plus 1 squared plus 2 squared is 4 plus 1. 4 plus 1 is 5, squared plus 4 plus 1. 5 squared is 25 plus 4 plus 1. And 25 plus 4 plus 1 is 30. The units of area in this case are square feet. And so, to put this into the table, which is a numerical way of representing a function, when t equals 2 seconds, the area of the rectangle will be 30 square feet. Here is a deeper question that you can ask, and that I will leave you to think about. Could you use the graph? How could you use the graph of a of t to answer the following question? At what value of t will the area of the rectangle be 100 square feet? That is a question for you to think about.